Welcome to the Deep Dive. Today, we're plunging into the mind of someone who, well, didn't just invent some tech. He fundamentally changed how we even think about using computers.
That's right.
I mean, the way you click around, organize things on your screen, a lot of that owes a huge debt to this one person.
Yeah, exactly. We're talking about Alan Kay, a genuine computing pioneer, a real visionary. His ideas, things like object-oriented programming, the graphical user interface we all use, they didn't just build technology. They changed our relationship with machines, made them personal.
That's it, exactly. So our mission here in this deep dive is to unpack those key moments, the big ideas from Kay's, well, incredible life and work. We've got biographical stuff, timelines. We want to get to the why behind the tech you use constantly, maybe without even realizing it.
Right.
Think of this as your shortcut to really understanding one of the absolute giants of digital history. So let's get into it.
Okay. So when you think about Alan Kay and just how huge his impact was, you might picture him, programming from birth. But his start was quite different. Alan Curtis Kay, born May 17, 1940, Springfield, Massachusetts. His family moved around a fair bit because of his dad's work.
And what jumps out right away is this intense curiosity. Even as a tiny kid, he learned to read fluently by age 3.
Yeah, it's pretty amazing. And by first grade, he'd apparently read about 150 books. He even famously said he knew the teachers were lying.
Wow. Okay, so clearly a mind that wasn't just accepting things at face value even then.
Definitely. And his path wasn't, a straight line either. Brooklyn Tech High School, then Bethany College.
Yeah.
Majoring in biology, minoring in math.
Biology, not computing.
Not yet. And get this, before any serious computing work, he actually spent a year teaching guitar in Denver.
Okay, jazz guitar to computer science guru. That's quite a pivot. How did the computing part even happen?
Well, it was almost by chance. He got drafted into the Army, but then qualified for officer training in the Air Force. And it was there, after passing an aptitude test, that he became a computer programmer.
So the military sort of pushed him in that direction.
Kind of accidentally, yeah. And that experience clearly sparked something, because then he went for formal higher education. Bachelor's in math and molecular biology from University of Colorado Boulder in '66.
And then he really dove deep into the academic side of computing.
Precisely. Fall of '66, he starts grad school at the University of Utah's College of Engineering. Got his master's in electrical engineering in '68, then his PhD in computer science in '69.
And his dissertation was FLEX, a flexible, extendable language. Sounds like early signs of his later thinking.
Absolutely. Already exploring adaptable software. And crucially, at Utah, he worked with David Evans and Robert Barton. Huge names, kind of the fathers of computer graphics. They were his doctoral advisors.
So the visual side of computing was there early on. Was Ivan Sutherland's work a factor too? I know Sketchpad was revolutionary.
Oh, massively. You hit on a key point there. Kay himself explicitly credits Sutherland's 1963 thesis, Sketchpad, as having a profound impact on his ideas about objects and programming. Well, Sutherland showed a computer as like an extension of the mind, interacting directly with graphical objects on screen. Just a radical concept back then, but it really clicked with Kay.
Interesting. So it wasn't just the tech specs, but how humans could interact and learn with these things.
Exactly. That really came into focus in 1968. He met Seymour Papert.
Ah, Logo, the educational
Oh,
language.
yeah. Papert introduced him to Logo, and that led Kay to explore the work of people like Jean Piaget, Jerome Bruner, Lev Vygotsky, giants in learning theory.
Okay.
And this really shaped his whole approach towards what's called constructionist learning, the idea that you learn best by actively building things, not just passively absorbing info. He started seeing computers as tools for thinking, for exploring, for creating.
And that same year, 1968, he saw something that must have just blown his mind, the mother of all demos.
Oh, yeah. Douglas Engelbart's demo in San Francisco, December 9th. Utterly transformative for Kay.
What was so special about it?
Engelbart showed off a working mouse, hypertext, networked collaboration, video conferencing, basically the integrated personal computing experience we know now, but decades early. Kay later said, even though he had a high fever that day,
He still went.
he still went. And he said it was one of the greatest experiences in my life. It wasn't just gadgets. It was a vision of how computing could augment human intellect. A huge seed planted right there.
Wow. Okay, so that really sets the stage for, well, probably his most famous chapter, Xerox PARC.
Definitely. That's where the revolution really started cooking. In 1970, he joined Xerox PARC in Palo Alto, spends the whole decade there developing these networked workstation prototypes.
And PRX was just legendary, wasn't it? Like a melting pot of brilliant minds rethinking everything.
It really was. And it's there Key becomes known as one of the fathers of object-oriented programming. He actually coined the term object-oriented.
Right, and he led the team developing Smalltalk, designing most of the early versions. That was more than just a language, wasn't it?
Oh, much more. It was a whole integrated graphical environment. But here's where it gets really, really interesting. A key aha moment, maybe. Despite coining object-oriented, Kay himself later said something like, "I'm sorry that I long ago coined the term objects, because it gets many people to focus on the lesser idea. The big idea is messaging."
Whoa, messaging. So not the objects themselves, but how they talk to each other.
Exactly. The communication, the interaction between these software components, that's what he saw as the core concept, the truly powerful part. It emphasizes the dynamic behavior over just static structure.
That completely reframes it?
Yeah.
Yeah, that's a deep insight.
It is. And also at PARC, he dreams up the Dynabook.
The precursor to laptops, tablets, e-books.
All of that. But crucially, he first envisioned it as an educational platform. He was one of the very first researchers thinking about mobile learning.
So like an iPad, but decades earlier and specifically for kids to learn and create. That's incredible foresight.
Truly visionary. It wasn't just about making computers smaller. It was about making them personal, portable, networked tools for kids to explore and build with.
And that idea eventually found its way into the real world, didn't it, with the OLPC project?
Absolutely. The one laptop per child, the children's machine, or XO1, the Dynabook concept was a huge influence there, and Kay was a key co-developer on that project, working with his friend Nicholas Negroponte, who founded it.
Amazing. And we can't forget the GUI at PARC.
Right. Kay was the architect of the modern overlapping windowing graphical user interface, the GUI.
So literally every time you drag a window over another one or click an icon, that's his design philosophy in action.
Pretty much.
Yeah.
That direct manipulation, the visual metaphor, it stems directly from his work and the team at PARC. A direct line from his thinking to how you interact with your computer right now.
It's just woven into everything. So what happened after PARC? She didn't just stop there, obviously.
No way. He kept innovating, kept pushing his vision. His career path after PARC was pretty diverse.
Yeah, he was chief scientist at Atari for a bit, 81 to 84, trying to bring some of that interactive vision to consumer stuff, I guess.
Right. Then he became an Apple Fellow in 84, back to the heart of personal computing. And later, in 97, his friend Bran Farron got him to join Disney Imagineering as a Disney Fellow.
Imagineering, applying his ideas to storytelling and interactive experiences. That makes sense.
Yeah. And in 2001, he founded the Viewpoints Research Institute, a nonprofit focused on kids, learning, advanced software development that ran until 2018.
He also kept ties with academia and industry labs.
He did. Senior fellow at HP Labs for a while, adjunct professor roles at UCLA, visiting professor at Kyoto University, adjunct at MIT, always mentoring, always teaching.
And he got heavily involved with open source too, right? Squeak, eToys?
Yes, very much so. That seems totally aligned with his philosophy of sharing knowledge and building collaboratively. Back in 95, while still at Apple, he worked on the open source Squeak version of Smalltalk.
And eToys came out of that.
Exactly, in 96. eToys was this media-rich environment where kids could actually program their own simulations and stories. Very Dynabook-like in spirit.
Makes sense. And more recently, the Croquet project.
Yeah, Croquet was about networked 2D and 3D environments for collaboration, working with folks like David A. Smith, David Reed, Andreas Rabe, pushing collaborative virtual spaces. And his group also developed Tweak, a new UI based on improving the eToys architecture in Squeak, always refining, always pushing.
Which brings us to that recurring theme of his, that the computer revolution hasn't happened yet. He gave talks on this, even his Turing Award lecture. What's he getting at there?
Well, he basically contrasts the elegance and power of those early pioneering systems, Sketchpad, Simula, Smalltalk, systems designed for users to really understand and create, with against what he sees as today's, well, bloated commercial software.
Bloated, meaning too complex, too hard to grasp.
Exactly. Too complex, too opaque. He argues that most users today can't truly master or even understand the tools they rely on. And this led him to propose this idea, steps, toward the reinvention of programming. It got NSF funding back in 2006.
And the core question was,
how small could we make a truly understandable yet practical personal computing system? Like a Model T for software. Could it be 1 million lines of code? 200,000,
Hmm.
100,000, maybe even just 20,000 lines.
20,000 lines.
Yeah.
Compared to the hundreds of millions in modern operating systems, that's radical.
It is radical. He's challenging us to find that essential core to make software elegant and comprehensible again. It's a callback to the original vision of personal computing, where the user has more control, more understanding, not just a consumer, but an active participant.
It really speaks to his whole philosophy. Elegance, simplicity, user empowerment.
Exactly.
Listening to all this, it's clear he's not just a tech guy. We mentioned the guitar playing early on. He seems like a real Renaissance man.
Oh, absolutely. Former professional jazz guitarist, composer, theatrical designer, and he's an amateur classical pipe organist, too.
Wow.
It's not just, random hobbies. It suggests a mind that sees connections, appreciates complexity and artistry across different fields.
And that breadth, that impact, it's certainly been recognized. The awards list is incredible.
It really is. The ACM Turing Award in 2003, the Nobel Prize of Computing. The citations specifically mentions pioneering object-oriented ideas, leading Smalltalk, and fundamental contributions to personal computing.
And the Kyoto Prize and Draper Prize, both in 2004, that's huge.
Yeah, 2004 is a big year. The Kyoto Prize is Japan's highest private award for global achievement. And the Draper Prize, shared with Lamson, Taylor, and Thacker, recognized that whole PRC team effort on networked personal computing. It underlines just how fundamental their collective work was.
And on top of those, countless honorary doctorates, fellowships, National Academy of Engineering specifically for inventing portable personal computing.
All right, American Academy of Arts and Sciences, Computer History Museum Fellow. The recognition is global, across disciplines.
Yeah.
It just shows how wide-ranging his influence has been.
It really does permeate almost everything we do digitally.
Mm-hmm.
Okay, so let's try to wrap this deep dive up. Alan Kay's impact. It's monumental, maybe even more than people realize day to day. From coining object-oriented and driving Smalltalk, to architecting the GUI, dreaming up the Dynabook. He didn't just build stuff. He shaped the entire paradigm. A true computing pioneer and visionary.
Yeah, and his constant push for simplicity, for power, for human-centered design, it's still incredibly relevant. That idea that the computer revolution hasn't happened yet, it's not just looking back, it's a challenge for the future, isn't it?
Definitely.
It reminds us there's still so much potential for technology to be more intuitive, more understandable, more empowering.
It's a really powerful thought to end on. If Kay's vision of a Model T computer built with maybe just 20,000 lines of understandable code, if that's possible, what does that mean for your digital future?
Yeah.
What if the tools you used every day were radically simpler, more flexible? What would true personal computing, in Kay's original sense, actually feel like? Something to think about as you click around in today's complex digital world.